Welcome to Module 5, Session 1. The course learning objectives of Module 5 are design applications of combinational circuits and sequential circuits. The contents of Module 5 are design of a sequence detector, guidelines for construction of state graphs, design example, design of an iterative circuits, design of sequential circuits using ROM and PLA, CPLDs and FPGAs, serial adder with accumulator, design of binary multiplier and binary divider. And the contents of session 1 are design of a sequence detector using Mealy and Moore model. Also, we'll study about different types of sequence detector, multiple choice questions on the contents related to session 1 and assignments related to the session 1. Here, the diagram shown is of a sequence detector which needs to be designed. We have an input sequence X and output sequence Z. And this sequence detector will detect an input sequence ending in 101. And when the input sequence ending with 101 is received, the output Z is equal to 1. And also the circuit does not reset when the output 1 occurs. Now we'll see for a typical input sequence, what is the corresponding output sequence Z. We have input sequence X, output sequence Z. Now when the input is 0, Z is 0. When X is 0, Z is 0. When X is 1, Z is 0. Now, since X is 1, we have received the first input for the desired sequence, what we are looking for, which is 101. Next, again, we got 1 here, so that we are reinitializing the sequence, so that the output will be 0. Next, we receive 0, 0. Next, we've received 1. Now, as you can see from this one, what we have is 1, 0, 1. So that the output will be equal to 1 here. Now 1, 0, 0, 0, 1. X is 0, 0. Now 1. Again, you can see the input sequence what we have 1, 0, and 1. So that the output Z will be equal to 1 here. Now again, you can see from this one 1, 0, and 1. So that the output is equal to 1. We have this input sequence 1, 0, 1. So the output is 1. Similarly, here also we have an input sequence 101. Therefore, the output is 1. Again, you can see from this one, we have the sequence 101, so that the output is 1. Now, for the given problem statement for the sequence to be detected, we'll use Mealy model and Moore model. When I say Mealy model, here the output is a function of input and present state. Now, if we see initially here, the initial state or the reset state is yes, not. The reset's initial state, what we have is yes, not here. And when the input is 0, when the input is 0, the next state is also equal to yes, not. Now here you can see here 0/0. This is return, like this is nothing but X/Z, an input sequence divided by the output. Like you can write it as X/Z, right? Similarly, When it is in the present state yes not and the input received is 1 here, it will go to the next new state which is yes 1 and the output is equal to 0. Output is equal to 0. Now here, now we look for the sequence. What the sequence what we're looking is 1 0 1. So that when the circuit is in state yes1 here and the input sequence received is 0, when the input sequence received is 0, it will go to the new state yes2 instead of the reset state, because the required sequence what we are looking is 1 0 1, and we have received the first two inputs 1 and 0 here, so that it will go to the new state yes2 instead of the reset state here. And when the circuit is in yes2 state and the input received is 1, now it completes the input sequence 1 0 and 1, so that the output for that is equal to 1, and it will go to the state yes1. And why it will go to the state yes1 here? As you can see here, 1 0 1, this is the last input in order to complete the sequence 1 0 1, but it is also the first input for the new sequence. That's the reason it will go from yes2 to the yes1 state. As I showed here, we have this sequence here 1 0 1, the output z will be 1, and also what we have 1 0 1 here, right? As you can, this is the last input for this sequence here, and this 1 is the first input for this new sequence here. And also here, again, this state table is not complete because we have done the transition for 0. Whatever the transition, when it is in state yes1 and the input received is 1. Similarly, yes2, we have given the transition for when the input is 1, it will go to the S1 state. But when it is in S2 state and the input received is 0, where it has to go? It was given in this final state graph here. Now in S1 state, if the input received is 1 here, 1, it will go to the S1 state itself because the sequence itself has reinitialized, and that will be our first input. And similarly, when the circuit is in S2 state and the received input is 0, it will go to the reset state because our sequence starts with what? 1 0 1, and what we received is 0 and 0, so that it will go to the reset state. Now from this final state graph will come with a state table. Now just for looking at the state graph, we'll write this table here. Now what we have it here. Now the present state is yes naught, so that we have written the present state here, yes naught, yes 1 and yes 2. Now the present state is yes naught and the input x is 0. When the input x is 0, the next state is also equal to yes naught. So that what we have, the present state is yes naught. When the input x is 0, the next state is also equal to yes naught. Similarly, when x is 1, when x is equal to 1, so that what we have here, when x is equal to 1, this transition, when x is 1, this is nothing but what? X. X, and the bottom what we have is z here. Right? When x is 1, when the present state is s naught, it will go to the next state as yes 1. So that what we have here, it will go to the state yes 1. And what is the output for this one? X is 0. X is 0, the output is 0, and x is, when x is 1, the output is 0. We have it here, 0 and 0. Similarly for S1, now the present state is S1 and the input received is 0. input received is 0, it will go to the state yes2. It will go to the state yes2 here, so that we have an yes2 state here, right? The output for this one is 0. We have 0 here. Now, in the when it is in present state yes1 and the input received is 1, input received is 1 here. It will, the next state is also equal to yes1 state, and output is what we have here is 0. Similarly, for yes2, when the present state is yes2 and the input received is 0, input received is 0, it will go from yes2 to the yes0 state, so that the next state will be yes0 when x is 0. Similarly, when received input is 1 in the present state yes2, it will go to the state yes1, so that will go to the state yes1. And what is an output for this one? The output is equal to 1, so that you have output 1 here. And we know, so for when x is 0, the output will be 0. Hope everyone understood how to come with a state table by looking at the final state graph. Now, once we have this one, now how to know the flip-flop states for this circuit states. Now here, how many states do we have here? We have yes0, yes1 and yes2 states. One flip-flop is required for 2 circuit states. Since we have 3 circuit states, how many flip-flops do we require here? We require 2 flip-flop, and we designate that as A and B, and S0 is given as 0, 0, S1 is 0, 1, and S2 is 1, 0 here, right? Now, since we have the mapping of flip-flop states, the circuit state, now we can come with a transition table. And how you can come with a transition table? Since we had the mapping of flip-flop states in the circuit state, now go back to the state table. In state table, now instead of S0, S1 and S2, we write the flip-flop states 0, 0, 0, 1 and 1, 0. Here what now? We write 0, 0, 0, 1 and 1, 0 here. Similarly, S0 is nothing but 0, 0. S2 is 1, 0. And this will be 0 and S1 is what we have? 0, 1, 0, 1, 0, 1. Similarly, what we have? This is 0, 0, 0, 0, this is 0, and this will be 1 here. So that now in this state table, we replace this S0 with this value 0, 0, 0, 1 and 1, 0. Once we replace all, we get a transition table. So that's what we have now. Now what we have now? A, B, we have a flip-flop sets A, B, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, all are S1, 0, 0, 0, 0, and 0, 1 here, right? Now, once we have this transition table, now come with what now? Now, come with the next state maps for the flip-flops and the output function Z. So that what we have now, A plus, B plus, and Z. Now enter the values. How do you write the values in this K-map and get the expression for A plus, B plus, and Z here? Now just by looking at this diagram, now what we have here, this is AB values 0, 0, 0, 1, and 1, 0. We don't have 1, 1, right? A1 and B1. We have only 3 states, S0, S1, and S2. So that for 1, 1, we write it as D. D stands for don't care condition or don't care term, right? So that when X is 0, right? Now what we have for A plus C, this one, this is B plus. So that what we have, A plus We have 0 here, 0, 1, 0, 0, and 0 here. Right? So that now how do you write now for this one? 0, 0, when x is 0, it is 0. 0, 1, when x is 0, we have it as 1. And 1, 0, when x is 0, it is 0. Similarly, when x is 1, when a and b are 0, 0, it is 0. And when x is 1 and ab is 0, 1, it is 1. And when x is 1, ab is 1, 0, it is equal to 0 here. And for 1, 1, you write it as D. So that now what we have now? We have 0, 0, 1, 0, D and D. This is 0 and 0. So that what is the expression you get? You group these two terms, which is a common term we have. This is B here, and this is x is 0. So for A plus is equal to x bar B. Similarly for B plus, how do you do this one? 0, 1, 0, 0, and 1 here. So that how do you write this one? When x is 0, both are 0, 0, it is 0. And when x is 1 and AB are 0, 0, this is equal to 1. Similarly, when x is 0, AB is equal to 0, 1, it is equal to 0. And when x is 1, AB is 0, 1, it is equal to 1. Similarly, for AB is equal to 1, 0, and x is equal to 0, it is 0. And when x is equal to 1, AB is equal to 1, 0, it is equal to 1 here. So that what is the expression? Enter all the values in the K-map, simplify, go for the maximum grouping here. So that what we get, this is nothing but is equal to B plus is equal to X. Similarly for Z, how do you write? Similarly write for this one, 0, 0, 0, 0, DD, and this is 0. And here it is 1. When X is 1 and AB is what? 1, 0. As we have it here. Then AB is this one and X is 1. Now, for this one, the output is 1 here. Now substitute these values in the K-map, simplify this one so that what is in output Z is equal to X ANDed with A here. And the implementation is shown in this one, in this diagram. And this is a Mealy type of sequence detector. Next, for the same given problem statement, now we'll implement the sequence detector using Moore model. Now, if you see in Moore model, when I say Moore model, the output is a function of present state only. And also if you see the state graph for this one as compared to the Mealy model, if you see in the Mealy model what we had x/z as part of the transition itself. We used to write the input and the output. But when it comes to the Moore model, as part of the state itself, we have written the output. We have the return the output here. For S1, we have written the output as 0. For S2, we have written it as 0. Now, how this works now? Now, when the present state is S0 and the input received is 0, the next state is equal to S0. And what is the output for this one? The output is 0. Now, when the present state is S0 and the input received is 1, it will go to the new state S1. And what is an output for this one? It is 0 here. Now, similarly, when it is in the present state S1 and the received input sequence is 0, it will go to the state S2. The output is 0. Why still the output is 0? Because we're looking for the input sequence 1, 0, and 1. When the sequence input sequence is received 1, 0 and 1, then only the output will be is equal to 1. Now, when the present state is yes2, when the present state is yes2 and the received input sequence is 1, it will go to the state yes3 here. If you see, if you compare this state graph for a Moore model with the Mealy model, in Mealy model, when the received input is 1, it was going to the state yes1 there. But here it will go to the state yes3. As you can see, why it has to go to the new state, because you can see here we have written the output as 0 here, right? But since we have received the sequence as what, 1, 0 and 1, so that since the input sequence is 1, 0, 1, the output has to be 1, so that it will go to the new state yes 3. So that just by comparing the Moore type and the Mealy type, the Mealy model, we know that this Moore model requires more number of states to implement any Boolean function. And this is still not complete, and the final state graph is given in the next state. Now what we have, when the input sequence is 1, it will go to the state yes1 here. It will go to the state yes1. Yes1. And when it is in state yes2 and it receives a 0, it will go to the state yes0, which is the reset state, because 0, 0 is not the required sequence what we are looking for. Now, just by looking at the diagram of a state graph, now we can easily come with a state table for this one. Now, how many states do we have it? Yes0, yes1, yes2, and yes3. Similar to what we have done for the Mealy state table. Now do the same for the Moore model too. So that what are the present state we have? yes0, yes1, yes2, and yes3. And there are two transition when x is 0, when x is 1. I'll explain for 1. Now when the present state is yes0, when the present state is yes0 and x is equal to, when x is equal to 0, the next state is also equal to yes0. So that what we have, when the present state is yes0 and x is 0, the next state is equal to S0. Similarly, when the present state is S0 and the received input is 1, the next state is equal to S1. So that the next state is equal to S1. And what is the present output for this one? This is equal to 0. Similarly, I'll explain for S3 here. Now the present state is S3, and for this one, when the input received is 0, when the receive is 0, it will go to the next state will be yes2. So that the next state is yes2 here. And when the input sequence is 1, it will go to the state yes1. So that what we have, this is yes1. And the output is equal to 1 here. Now once the state table is done, now construct the transition table for this one. Now, since we have 4 states, we require 2 flip-flops, and these 2 flip-flops are designated as A, B. We have A plus and B plus, so that what we have, yes0, yes1, yes2, and yes3. Now, by looking at the state table, we can easily come with a state transition table. S0 is replaced with 0, 0, S1 is replaced with 0, 1, and S2 is replaced with 1, 1, and S3 is replaced with 1, 0. You get the state transition table. Similarly, what we have done for the Mealy model, for this also, now using K-map, come with a next state, maps for the flip-flops and the output function Z, and implement using D flip-flop. Now we'll see different types of sequence detector. There are two types of sequence detector. The first one is sliding window sequence detector. The sequence being detected can occur anywhere in the input sequence. The windows can be overlapping and non-overlapping. We already seen what you mean by overlapping. As I was explaining, for typical input sequence, the corresponding output sequence Z, explained that when it is 1 0 1 0 1, right? 1 0 1, that 1 is the last input for the required sequence, and that the last 1 is also the first input for the new sequence, so that this becomes what? An overlapping sliding window sequence detector. I'll explain again by looking at this table. The second type of sequence detector is disjoint window sequence detector. In disjoint window sequence detector, now here the input sequence is divided into windows of fixed length. In the table what we have now, here we divided this input sequence of length 3 here. I will explain the various types of sequence detector with this through this table. Now, the different input sequence 101 sequence generator and the typical input sequence is shown here. We have input sequence X is 0, 1, 0. Now for sliding windows, it says overlapping here, right? So that what is an output for Z now? Now what we have 0, 0. This is 1 and 0, 0 and 0. Now what we have, since it is overlapping, what we have it here, you can just by looking at this one. Now what we have here, 1 0 1, so that now the output is equal to 1. Similarly what we have, 1 0 and 1. Next what we have, 1 0 and 1. Now as you can say here, the last input for the previous sequence is the first input for this new sequence. This one is overlapping here, right? This is called as overlapping sliding window sequence, so that the output is equal to 1. Similarly what we have, 1 0 and 1. Next here again you can see here what we have, 1 0 and 1, so that the output we have, output is equal to 1 here. Now next we have 1 here, it is 0, right? Next 1 0 1 0 0 1 and 1. Again what we have, the sequence 1 0 1, so that the output is equal to 1. Similarly what we have, 0 and 1. Now we have 1 0 and 1, so that the output is equal to 1. This you call it as what? Overlapping sliding windows sequence detector, right? Hope everyone understood this one. Similarly we have 1 0 1, and again we have here 1 0 1. Next, sliding windows non-overlapping. They should not be overlapping digits here. So that now what we have, now this is X is 0, right? So that Z is 0 here. Now X is 1, 0, 0 we have it, 0. So now what we have it now here, 1. I'll just clear this one. Now what we have, this, as you can see this one, it's a non-overlapping. Now what we have, 1 0 1, so that one, now what we have, the output is equal to 1. Next what we have, 0, right? The output is 0, and now it is 1 and it is 0 here. If you see in overlapping, this is equal to 1, but for non-overlapping it is equal to 0, because we are looking for non-overlapping input sequence. We should get 1 0 1 here, but you can see from this one, as I said, this is overlapping. The 1 is common to both of this input sequence there. Similarly, what we have now, we have 1 here, 0 1 0 and 1, so that the output is equal to 0 here. And for non-overlapping input sequences, it will generate the output Z is equal to 1. This we call as a non-overlapping sliding window sequence. Similarly, when overlapping, when the initial value is 1, in the sense, I will assume that the initial value is equal to 1 for this one. Since the initial value is 1, the next input is 0, and again the next input is 1. So that what is the sequence we have it now? 1 0 1. So that the output Z is equal to what now? 1 here. And similarly, non-overlapping initial 1. Non-overlapping initial also same. 1 we have it, 0 and 1. Since it is 1 0 and 1, the output will be 1. The rest of the sequence, as I said, it is applicable as per the overlapping and non-overlapping sliding window sequence. Next, what we have is a disjoint windows. Now here the disjoint window length is 3. Now what we have, 0 1 and 0, right? This is not the required sequence. The required sequence is 1 0 1, so that it is 0 here. Next, what we have, 1 0 1, so that output is equal to what? Now when it is 1 it is 0, when it is 0 0, and when it is 1 the output is 1. It will look for only these 3 sequence here. If that input sequence is received here, the output will be 1. Similarly here, what we have, 0 1 1. This is not the required sequence, so that the output will be 0. Next, what we have, 1 0 1. This is a required sequence, so that what we have, 0 0. Once all the 3 inputs are received, 1 0 1, the output Z is equal to 1. Next, what we have, 0 1 0. It is not a required sequence, so that it is 0. Next, again what we have, 1 0 1, so that we have 0 0 1. These are the different types of sequence detector, right? Now we'll go to the next slide. Now we'll look at multiple choice questions. Now the question what is given here is a clocked Mealy sequential circuit with one input X and one output Z is to be designed. Now we need to design a sequence detector of Mealy type. The output is to be 0. The output is to be 0 unless the input is 0. Unless the input is 0 following a sequence of exactly 2 0 inputs followed by a 1 followed by a 1 input followed by a 1 input. Specify the output sequence Z for each of the following input sequences given in questions 1 to 3. Right? Now here what it says is that, the output is to be 0 unless the input is 0 followed by a sequence of exactly 2 inputs followed by a 1 input. What to understand by here? It means that when the input sequences is 0 0, right? A 0 following a sequence of exactly 2 0 inputs, we have 2 followed by 1, and we have 0 here. When the input sequence is something like this, 0 0 1 0, at that time the output will be 1. For other input sequences it will be equal to 0. Now For various input sequences which are given in questions 1 to 3, find the correct output Z. Now what we have now? 0, 0, 1, 0, right? Now what is the value of Z now? Now, as we know that the sequence will start with 0. Again, we received a 0 here. Next, it is 1 and this is 0. So that what is the sequence what we are looking here now? It is 0, 0, 1, 0. So that what will be the output for this one here? Now, since it is 0, 0 here, 0, 0 here, there's a 0 here. And since now we received all the 4 inputs, so that Z now will be 1. So that which is the correct option for this one? C is the correct option. Next, what we have? Second question. X, what we have is 1, 0, 0, 1, 0. Here, dash means any input sequence not ending in 0, 0, not ending in 0, 0. Now, which is the required? This one here, answer for this one. As you can see here, 0, 0, 1, 0. So that what we have? We have 0, 0, 0, 0, and we have it as 1 here. Right? So that the right answer is option number 2 for question number 2. Similarly, for the third one, X is equal to 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0. Right? Which is the correct options for this one now? Now what we have? We have it here. Right? Again, you can see for this one what we have. So that which is the right option for this one, just by looking at this one. Now 0, 0, 0, 1. We have it. Again, what we have it from this one, as you can see here, as we have it here, 0, 0, 1, 0, 0, 0, 1. Right? So that which is the right answer for this one, just by looking at this one, we know that the correct option is A here. Right? Right? This is the correct option. Now we'll go to the next one now. Fourth question. Add arrows to the following state graph so that the sequence X is equal to 0, 0, 1, 0 gives the correct output. Now sequence what we have is 0, 0, 1, 0. Add rows to the following state graph so that the sequence X goes to sequence 0, 0, 1, 0. Now how many states we have it? S0, S1, S2 and S3. Now you put the arrows so that the sequence will be 0, 0, 1 and 0 here. Now how do you do this one now? How do you write this one now? Now we have 0 here. It will go to S1 state, 0 S1, and this is 1. Now what we have? 0, 0, 1. And again, we need transition for when the input is 0. So that this option is not the correct answer. Next, as you can see here, we don't have any transition between S0 and S1. So that this is also not the right option. Next, what we have, I can see we don't have transition from S2 to S3. Now, D option, what we have, 0, 0, 1 and 0, right? So that now the sequence is what we have, 0, 0, 1 and 0. So that the output is equal to 1 here. So that which is the right option for this one now? It is D. Now we'll see the question number 5. For a Mealy machine circuit with input X and output Z, the state graph is having the value, 1/0. What is the value of X and Z? We already looked at the Mealy model for the input sequence 101, how the transition happens and how and where the input and values are given, how input X and Z values are given. So which is the right option for this one now? Now, this is nothing but what? X/0. Therefore, X is 1 here, Z is 0. The right option is C. Now, similarly, question number 6. In a state graph for a single input variable, each state must have dash exit lines. How many exit lines we have? For X is 0, X is 1. So that the right option for this one is B. Now question number 7. For the given state graph, identify the corresponding state table. Now this is a huge work. Now how you start with this one now? Now look for the present state, next state when X is 0 and X is 1 now. How do you look now? Now present state is yes not here. When it is 0, it is going to the yes 1 state. When it is yes not, when X is 0, it is going to the yes 1 state. That is correct. And similarly, what we have now, when it is 1, right, the next state is equal to yes not. When it is 1, it is equal to the yes not. And what was the output for this one now? Output is 0. Output is 0 here. And this is also for this one, the output is 0. Similarly, when it is the present state is yes 1 and the received input is 0, it will go to the state yes 2. So that yes 1 is here. When it is 0, it will go to the state yes 2. Similarly for yes 3, right? Now for this yes not, when it will go to the yes not state, when the received input is 1. When the received input is 1, it will go to the yes not state. So this is correct, this is correct. And what is the output for this one? 0 and 0 here. Sorry, here 0 and 0. So this is 0 and this is 0. Similarly for yes 2, when it receives 0, it will go to the state yes 4. Yes 4 here, the output is 0 for this one. And when the received input is 1, the output is 0. It will go to the state yes 3. And this is from yes 2. Right? What is the received input here now? Now here it shows it as 1 now. Here it is given as 1 now. Right? The output is 0. Right? It means that this is not the correct. Right? Similarly for this one, you can see here. Now what we have yes 4 here, we have yes 3 here. This is yes 1 and yes 3. And now look for when yes 2 to this one, right? So that this is also wrong, because when the present state is yes 2 here and X is 1, the output is 0 here. It will go to the yes 3 state. It will go to the yes 3 state here. Right? So that when it is yes 3, right, and X is 1 and X is 0, it will go to this one. This is correct option. This is the correct option, and this is wrong what we have. Now similarly, check for the other two options now. Okay, I've written this, just make the correction here. Any one of this options here, make the corrections for this one. Now here, as I said here, everything is correct except this one. Make the correction. This should be 0. Make this as 0, and so that it will be correct. Make the correction in this one. So the correct option for this will be A. As you can see for yes 4 also, from it is yes 4. If it is 0, it will go to the same state. So that this option is correct. And when it is 1, it will go to the yes not state. In that sense, everything is correct. Since there was a mistake with this one here, make this as 0 so that this option 1 will be the correct. Please make this as 0. Now we'll go to the 8th question. For a 110 disjoint Windows sequence detector of length 3, write the output Z for the given input sequence X. Now it says disjoint Windows and the length for this one is 3. Now how do you write for this one? And we're looking for the sequence 110. Since we're looking for the sequence 110, where would we have 110? Here. So that here it will be 1. Right? For rest of things it will be 0 here. 0, 0, 0, 0 and 0. So that this is 0, 0 here. Right? Next what we have again are do we looking for, this is not the required sequence, this is also not, this is also, it is only for this one. So that what we have 8 zeros, after that 1 we have it here, 8 zeros and 1. Please make sure if it is mistake there, remove 1 0. Right, so that what we have 1 1 1 1 1 1 1 and we have it this one as what now 6 and 1. Yeah, correct, we have it as 1 here. Right, 8 zeros and 1 we have it here. So that where this is the correct option. Here we have 2, we don't get it 2, this is not the correct one. Similarly this is also not, this is also not. So that the correct option is A for the 8th question. Now similarly go to the question number 9. For a 11101 overlapping sliding Windows sequence detector, write the output Z for the given input sequence X. Now it says overlapping. Now since it is overlapping, what we have it now? We have it here. We have it here. And we have it here. So that we get 1 here, we get 1 here, and we get 1 here. This is 0. This is 0. 0. This is 0. And this is also 0. So that what we get now 0 0 1 0 1 0 1 0. So that where do we have this option now? 1 0 1 0. It is option number B. Now question number 10. For a 101 non-overlapping sliding Windows sequence detector, write the output Z for the given input X sequence. Now it says non-overlapping. So that non-overlapping, how do you do it? This one and this one. So that here we get 1 0 0 0 1 0 0 0 1. So that what we have 0 0 0 1 0 0 0 1 and 0. The option A is the correct. We should get it as 2 ones. So that the option number 1 A is the correct answer for question number 10. And the assignment questions are: design a Mealy type sequence detector to detect an input sequence 101. Design a Moore type sequence detector to detect an input sequence 101. Construct Moore and Mealy state diagram that will detect input sequence 10110 when input pattern is detected. Z is assigned when input pattern is detected. The Z is assigned high. Give state diagrams for each Moore and Mealy models. Thank you.